Okay, so what we're going to do today in this lesson is we're going to find time. We're going to find time. All right, let me explain what I mean by that. So far, in all of these equations that you have now written on your formulas to know paper, remember that paper I gave you guys and I wanted y'all to keep your formulas on because you could use that paper later? You've written all of these formulas down already, but I want to remind you guys of something. Up to this point, what have we found with all of these formulas? What have we found with all of these formulas so far? What have we been finding? In every one of these formulas so far, we've been finding what? We've been finding A. We found A. That's what we've been finding, right? Today's lesson, we're not finding A. What are we finding? We're finding T. We're finding time. Well, here's the thing. Here's the trick. Where is time? Where is it located in these formulas? It's in the exponent spot. So here's the deal. Instead of us just getting to just straight type everything into our calculator because we've been given everything on the right side, we're going to have everything given except for time. So we got to do a little work, and then we can use our calculators to find T. But you got to remember this. There's three important things today. One, you got to use the right formulas. Okay? That's essential. If you're not using the right formulas, you can't come up with the right answer. Right? Second, you got to make sure that you are plugging these into the right spots. Okay? And then the final thing is you got to remember, to solve for T, you've got to rewrite that exponential equation as a what? How have we solved these? You rewrite an exponential equation as a You rewrite the exponential equation as a You rewrite the exponential equation as a what? Come on, guys. How do we solve exponential equations? We rewrite them as what have we connected in this unit from day one? Logarithms. If I want to solve an exponential equations, I'm going to rewrite them as logarithms. And that's exactly how we find time. That's how we find time today, okay? So here we go. First, you got to use the right whats? You got to use the right formulas. Okay, look at number one. Or I guess technically it's letter A. You invest $3,000 into an account with 5% annual interest compounded continuously. Compounded continuously. How long will it take for your money to double? Okay, before we start writing anything into these equations, what equation do I have to use here? I've got to use A equals P E to the RT. Right? I got to use compounded continuously formula. So here we go. You invest $3,000 into an account. Guys, what's that 3,000 stand for? Stands for my P value, right? I got to put 3,000 in P. Don't we know that E is a mathematical constant? You don't plug anything into E. E is E, right? All right, next it says 5% annual interest. How do I write 5% and where do I write it? Okay, it's 0.05 and we replace R with it, right? So 0.05 is R. And it says, how long will it take? Guys, isn't how long will it take? Isn't that T? Here's the key to the problem though. How long will it take to do what? Double. Double. Well, what was it originally? It was 3,000, right? What's double that? 6,000. So my A value is 6,000. That's what I want it to grow to. I want it to double. So I want it to grow to 6,000. Okay, now, we've used the right formula. We've plugged everything in the right spot. here's how we finish this thing off. Remember, when we solve an exponential equation, we've got to isolate that base. Well, the base of 0.05t is what? E. So we got to move 3,000 away from it. How? Not subtract it. It's not being added, is it? What is it doing to it when it's right next to it? It's multiplying, so we break it away by dividing. So first, guys, go 6,000 divided by 3,000. So 2 will equal e to the 0.05t. Now, remember when we did this? We always did the loop. Remember the loop? But we always did the loop from left to right. So a lot of times what I encourage people to do is just rewrite it where you have your exponent on the left side so you can follow the loop. You don't have to do that, but I do think it helps in a lot of cases. All right, so look at this, guys. We have an exponential equation, but we have a specific one. It's base e. What logarithm do we rewrite this with? Base e. We use ln, natural log. So here we go. Remember how we do this? ln, understood base e of what? ln of 2 equals what? 0.05t, right? So think about this, guys. What's the last thing I'm going to do to solve for t? I'm going to divide by 0.05. So I want you to go to your calculator, and I want you to type in ln of 2, close that parenthesis, and then divide it by 0.05. ln of 2, and divide that by 0.05, and tell me what you get. So 13.86. So it's going to take approximately 13.86 years. And that's how you do it. That's how you find time. Did we learn anything new here? No. We incorporated things that we'd already learned in the past to formulas, just solving for something we hadn't solved for yet. Okay? We hadn't solved for time yet. Now we're solving for time. Look at number 2. Well, technically it's B. In 1985, there were 285 cell phone subscribers in the small town of Centerville. The number of subscribers increased by 75% per year after 1985. In what year did the cell phone subscribers equal 43,871? All right, so first, let's make sure we're using the correct what? Formula. So what do y'all notice about this one? Is it compound interest? Is it compounded continuous? Is it appreciation? Is it depreciation? Is it double? Is it triple? It's appreciation, right? It's just per year. It's just appreciation. Appreciation is A equals P times 1 plus R to the T power. That's it. So here we go. Let's start filling these in with what we know. First, do we know what 285 represents? That was the original, right? 285 is P. The next number I see is 75%. What's that? That's R, right? That's our rate. That's how it's increasing. So that's 1 plus, because it's appreciation, 0.75. In what year, so we're trying to find T, did the phone subscribers equal 43,870? That's A. That's the total amount. Okay? So here you have it. So here's what I want to do. I know that the base of T is this value right here, isn't it? Isn't that 1.75? What do I need to do, though, with that 285? I got to divide it. So go to your calculator and type 43,871 divided by 285. And tell me about what you get. 153.93 equals 1.75 T. Now again, real quickly, I'm just going to swap those sides, okay? I'm going to put 1.75 to the T power equals 153.93. The only reason I'm doing that is because so far we've always done the loop from left to right, and I want to continue that. Now, this time, is my base E? No, then we're not going to use ln. We're going to use what? We're going to use log, right? Log. So I'm going to write log. Remember the rule? The base of your exponent becomes the base of your log. Well, what is the base of my exponent? 1.75. So log base 1.75 of what? And that equals what? It equals just t. There's nothing with t. It's just t. So all I got to do is go type this into my calculator. Now again, where do I find that in my calculator? Alpha window number 5. Okay, you can't ask me that during the test. I can't remember how to get back to log base. You got to know where these buttons are. Alpha window number 5. Okay, now type it in. Log base 1.75 of 153.93. So it's 8.99 something, right? So let's just round that to what? It's going to take 9 years, right? But is that the question that it asked? It says, in what year? So if it's going to take 9 years from 1985, what is 9 years after 1985?
1994.
So it's going to be there in 1994. That's the real answer to this question, 1994. If you put 9 years, for me it's not wrong because you did all the work correctly, but just be careful. Sometimes the questions are asked a little differently. So that's number B. Letter B. Let's go to letter C. A car valued at $22,000 depreciates. So what formula am I using? I'm using depreciation. That's A equals P times 1 minus R to the T power. You got to use the right formulas. Okay, so here we go. It started at what amount?
22,000.
So that's my, no, that's my P value. It depreciates at a rate of 14%. That's 0.14. We want to know how long is it going to take for it to do what? How long is it going to take to be what? Half of its original value. If the original value is 22,000, what's half of that? 11,000. So A is 11,000. So here we go. Here's the base of my T, right? 1 minus 0.14. What do I got to do with 22,000? Divide by 22,000. A lot of times people like to divide the big number by the small number. If you do that, this problem is wrong. You're dividing by 22,000. What's 11,000 divided by 22,000? It's 0.5. So 0.5 equals 0.86 raised to the T power. Let's swap that around. That's 0.86 to the T power equals 0.5. So how do I solve this thing? Rewrite it as a log. So log, what's the base of my exponent? So log base 0.86 of what? Of 0.5 equals what? Equals T. So alpha window number 5, log base 0.86 of 0.5 equals approximately what? So about 4.6 years? About 4.6 years. And that's all this one asks, so you don't have to do anything tricky to that. There it is. It takes about 4.6 years. Okay? All right, last one. Last one is not above. It's not the formulas above. Okay, look. It says a culture contains 35 bacteria that what?
Doubles every minute.
Y'all remember the doubles formula? It's on your formulas to know worksheet. It's A equals P times 2 to the T. Again, I know it's not on the 4 that we're above, but you still have to know it. It's on the formulas to know note sheet. So it's P times 2 to the T. Again, the key word was it doubles. It could also say triples, and that would change that to a what? 3. All right, so here we go. Let's see what 35 is. What's 35? That's definitely the initial value, right? We know that the formula doubles, so that's 2. But it's every minute. How long will it take to become 4,500? So we want to know T, and we want to know how long it's going to take to get all the way to the A value, 4,500. So again, once we've done this a couple times, it starts getting kind of easy, doesn't it? What is the base of T? 2. So what do we get rid of? 35. How do we get rid of it? We divide. So you go to your calculator, you do 45 divided by 35. I'm sorry, 4,500 divided by 35. So 128.57 will equal 2 to the T power. Again, I like to switch it because we've always done the loop from left to right. Again, I keep saying that because in my opinion, the more repetitive you do things, the easier it is to do them. So the base of my exponent is 2, isn't it? So that becomes the base of my log. So log base 2 of what?
128.57.
And that equals 3. And I go one more time to alpha window number 5. So 7.006. So pretty much T equals 7. But it was 7 what? 7 minutes, right? 7 minutes. Because that's what it says. It's doubling every minute. So 7 minutes. So there you have it. That's your notes for finding time. So your homework is this back sheet. All 5 problems, numbers 1 through 5. Okay? Use the right formulas, plug things into the right spots, and then of course rewrite it as a logarithm. Ln if your base is E, log if your base is anything else. Okay? Alright, so that's it. Any questions? Don't forget, if you have any of those first four assignments that are missing from Synergy, they're due before the end of the day today. If they don't say that they're turned in by the 23rd of February, they become permanent zeros. Second, if you're missing a quiz over there, you got to come either tomorrow, Wednesday, or Thursday during homeroom. Last thing is the next day you're here in class, what are you supposed to bring? Your Chromebook and headphones to watch the review. The second day you're in here, you're going to be taking a test, okay?